polynomials, we are looking at the remainder theorem and the factor theorem. So the remainder theorem states that when a polynomial p of x is divided by x minus a, the remainder is given by evaluating p of x for x equals a. Now let's unpack that a little bit. Remember that we can write our polynomial division px equals x minus, now we're going to make it x minus a, multiplied by the quotient in x plus the remainder. Now, what we want for the remainder theorem is to find out what value of x will give us just the remainder. And quite obviously, since x minus a times the quotient gives us is happening here, if we want to cancel all of this out, one of these will have to be 0. And if x was equal to a, then a minus a would cancel out. This would be 0 times the quotient, which would mean all of this was 0. So when x is equal to a, that is the opposite sign of whatever number is in the brackets here of our divisor, evaluating the polynomial for a will result in the remainder. So that's saying that the polynomial at a is 0 times the quotient plus the remainder, so p of a equals the remainder. So this means that we can find the remainder in any division without actually doing the long division. And this is useful because we'll come back to the factor theorem, but it also does mean that if you've got spare time, you've got a little check to make sure that you got your remainder right, because it's quite quick. So our question is to find the remainder when this polynomial is divided by x minus 2. So remember our little trick. Having the formula say x minus a just means we want the opposite sign to what's here. So a equals 2. And we're going to evaluate the polynomial for a. That will be 2 cubed minus 5 times 2 squared minus 2 plus 4. 8 minus 20 minus 2 plus 4 equals negative 10. So evaluating the polynomial for a gives us negative 10. Therefore, the remainder is negative 10. And we could check that if we wanted by dividing this into that polynomial and checking that we got the remainder. Another example if you want it, skip if you don't. A is negative 1, so we evaluate our polynomial for negative 1. That's negative 1 cubed minus 5 times negative 1 squared minus negative 1 plus 4. Using the brackets really lets us follow what's happening to our negatives. Negative 1. Now, negative 1 squared is 1. 1 times negative 5 minus 5 plus 1 plus 4 minus 6 plus 5. That is negative 1. Therefore, our remainder is negative 1. So we can find the remainder using the remainder theorem for any polynomial division. Now where that comes in really